Welcome to the Gen AI Daily Briefing for Saturday, August 8th, 2026. The most consequential story today is OpenAI tapping the brakes on Astra, an in-development model that apparently crossed what it calls a critical cybersecurity threshold. The company says the model demonstrated enough capability to independently identify and execute attacks against well-defended real systems that it paused internal activities around the model while strengthening safeguards. That matters for two reasons. First, it's one of the clearest public admissions, yet that frontier capability gating is shifting from abstract policy language to operational deployment friction. Second, it reinforces that cyber is becoming the first truly hard capability boundary for general models, more concrete than the usual hand-wavy AGI talk. If you're running model evaluations inside an enterprise, this is a useful signal. Benchmark suites need to include not just accuracy and latency, but adversarial autonomy tests, tool use escalation, and evidence of persistence across multi-step tasks. The industry is moving from can the model answer security questions to can it chain actions into a real exploit path. That's a different risk class entirely. Next up, on the science side, DeepMind's WeatherNext is getting strong attention for cyclone and hurricane forecasting. The notable detail is not just accuracy, but that it reportedly achieves it using lower resolution weather inputs than traditional systems. That implies a better learned prior over atmospheric dynamics rather than brute force dependence on ever finer simulation grids. For technical leaders, this is another sign that foundation model style approaches are maturing in scientific forecasting domains where the win condition is not fluent language, but structured spatiotemporal reasoning under physical constraints. If this result holds up operationally, the interesting downstream effect is economic. Lower resolution inputs can reduce data and compute burdens for national weather services and insurers, while still improving path and intensity forecasting. That's one of the clearest examples of AI not just summarizing a domain, but materially compressing the cost of a high-value predictive workflow. On the infrastructure side, Anthropic reportedly plans to design its own hardware for Claude. This is one of those moves that sounds incremental until you zoom out. Model companies have spent the last few years pretending hardware is someone else's problem, then discovering that inference economics, latency jitter, memory bandwidth, and supply chain access are in fact product strategy. Custom silicon does not mean Anthropic will suddenly rival Nvidia's general-purpose ecosystem, but it does suggest the leading labs now believe there is enough stable workload shape in large scale serving to justify specialization. Expect the first gains to come less from raw peak performance and more from power efficiency, memory hierarchy tuned to transformer and post-transformer serving patterns, and tighter co-design with compiler/runtime stacks. The broader market message is clear. The frontier labs are no longer content to compete only on models. They want leverage over the full cost stack. Worth flagging alongside that, ByteDance is reportedly training a 10 trillion parameter model to compete with OpenAI and Anthropic. Parameter count is not capability, and at this point, most experienced teams know that architecture, data curation, post-training, and inference time compute matter at least as much. But the headline still matters because it shows ByteDance is willing to play the frontier game at true hyperscale. The more interesting question is where that model lands. ByteDance has distribution, consumer engagement data, recommendation expertise, and a global app footprint, which means it may not need to win the generic chatbot race to be strategically dangerous. A model tightly integrated into content generation, commerce, and creator tooling could be far more monetizable than another smart assistant. So I treat this less as a pure research flex and more as evidence that the next wave of competition will come from companies with both model ambition and native demand surfaces. Now to agent infrastructure. Cloudflare launched Kitesurf, a browser built for AI agents rather than humans, and separately open-sourced an internal vibe coding and agent workspace platform. Kitesurf is the more strategically interesting piece. Browser automation has become a hidden tax on agent systems because full Chromium stacks are heavyweight, brittle, and not really optimized for unattended machine use. A cloud-hosted browser, stripped down for common agent tasks, could improve resource efficiency and operational reliability, especially for workflows like form completion, web navigation, and verification loops. This is the stack maturing in public. Not just better models, but purpose-built substrates for agent execution. The key architectural question is whether the agent browser becomes a standardized runtime, like a headless OS layer for web agents, or just another vendor-specific wrapper around fragile web automation. Either way, it confirms that agent infrastructure is moving down stack and getting more opinionated. On the product and business side, OpenAI says ChatGPT free and Go users will get unlimited text chats, plus a think button for more complex queries. The immediate takeaway is that text inference costs are falling enough, or user monetization is improving enough, that rate limits on basic text interaction are less strategically useful. This is a classic funnel move. Keep the free tiers sticky, reserve premium value for richer modalities, deeper reasoning, workspace features, and enterprise controls. It also pressures competitors. Once unlimited baseline interaction becomes table stakes, differentiation has to come from reliability, tool use, memory, and integration rather than access scarcity. The think button is also revealing product language. We are moving toward explicit user-selectable reasoning budgets, where the product surfaces a trade-off between speed and deliberation instead of hiding it behind one default path. Also on the enterprise operations front, Rippling launched an AI spin console after discovering its own internal AI bill ballooned quickly. This is a small story with big legs. Most enterprises still have no coherent system for measuring AI usage at the employee, team, and workflow level across a growing pile of vendors and subscriptions. FinOps for cloud took years to mature. Now we're watching the birth of AIOps governance on the cost side. The subtle but important shift is from asking, are people using AI, to which usage produces measurable output, quality, or cycle time gains. Architecturally, this pushes buyers toward centralized identity, procurement, and telemetry layers for AI tools. Economically, it means the next enterprise software category may not just be copilots, but spend observability and ROI enforcement across all the copilots teams already adopted ad hoc. Finally, a few research items from AR14 are worth your attention because they map directly to real system pain. One paper on selective context preference optimization argues the challenge isn't simply making models robust to bad context, but teaching them when to trust context and when to resist it. That's exactly the failure mode in retrieval and tool-augmented systems. A model that ignores external context looks robust on paper and useless in production. Another paper, TragDebug, focuses on locating the earliest critical failure in long-horizon agent trajectories, which is effectively observability for agentic systems. If you've tried to debug a 40-step workflow that collapses at step 38 because of a subtle error at step 7, you know why this matters. In a third paper, AVAVOT shows a way to evaluate agents in imperfect information settings much more cheaply while preserving statistical validity under any time stopping. Translation: faster, cheaper agent evals without fooling yourself with bad confidence intervals. That's exactly the kind of tooling the ecosystem needs if agent benchmarking is going to become an engineering discipline instead of a demo sport. What to watch next? First, whether other labs publish similarly explicit capability-triggered slowdowns in cyber and bio. Second, whether custom silicon plans for model vendors turn into real deployment advantages or just expensive signaling. And third, whether agent infrastructure companies can standardize execution, debugging, and evaluation before the market fragments into bespoke stacks. That's your briefing. We'll see you tomorrow.